Welcome, everyone. While most people were distracted by the public stumbles of other AI platforms, Google quietly released something extraordinary. It is called Alpha Evolve, and honestly, it changes everything. This is not just another language model. Alpha Evolve improves code, designs chips, optimizes massive data centers, and even solves math problems that have remained unsolved for over 50 years. But the most shocking part is this. Alpha Evolve is now improving the AI systems that power Alpha Evolve itself. This is the first working example of a feedback loop that pushes us toward artificial general intelligence. It is already running, and it is already working. To be clear, Alpha Evolve does not just generate code. It creates a full system of language models that improve algorithms through iteration. Each part of the system plays a role. One model generates possible improvements to an existing algorithm. Another evaluates the results based on performance. A third manages memory and tracks changes. The system repeats this process over and over, keeping only the versions that work better. This is not trial and error. It is structured evolution. Unlike traditional code tools, Alpha Evolve can take a poor algorithm and make it better without any human rewriting. The human defines what success looks like by setting the goal. Alpha Evolve then figures out how to reach it. This mirrors how evolution works in nature. It uses selection and feedback to produce better outcomes through variation. What makes it powerful is speed. It compresses years of expert refinement into just a few days. At the foundation of Alpha Evolve are two major models. Gemini Flash handles broad idea generation. Gemini Pro focuses on deep reasoning. Together, they explore many possible changes and choose the ones with the highest potential. This division allows for both creativity and rigor. Flash gives you range, Pro gives you precision. Combined, they produce results that even the best human teams could not achieve in the same time frame. Alpha Evolve was tested inside Google at massive scale. In one project, it improved data center efficiency by developing a new scheduling algorithm. This change reclaimed 0.7% of Google's entire global computing capacity. That might seem small, but at Google's size, it equals building multiple new data centers without laying a single brick. This is not a theoretical gain. It already happened. In hardware design, Alpha Evolve improved the layout of circuits inside Google's custom chips. These chips already had years of human optimization, yet Alpha Evolve found improvements in the Verilog code that even the top engineers had missed. It simplified circuit paths and increased efficiency without changing functionality. This shows that AI can now participate in fields where precision and reliability are everything. The system also made breakthroughs in mathematics. One of its most notable results was an improvement to a matrix multiplication method that had not changed in over 50 years. This required finding a way to reduce the number of calculations needed when multiplying complex matrices. Alpha Evolve succeeded. It found a solution using fewer steps, saving time and energy in high-level computing tasks. The algorithm it discovered replaced part of the widely known Strawson method. Alpha Evolve showed that it could go beyond refining known techniques. It could invent new ones. These discoveries matter because they affect every part of computing. Faster matrix math makes everything from AI training to image processing more efficient. These are core operations, and improving them has system-wide effects. Alpha Evolve also demonstrated what researchers call fleet learning. When one version of the system finds a better solution, that update can be shared across all instances running elsewhere. This allows knowledge to spread instantly. It mimics how human teams share best practices, but at digital speed. Improvements made in one domain can transfer to others, enabling compound gains across software and hardware environments. Its design uses automated evaluators to score performance. These are not vague metrics. The system actually tests exact execution speeds, energy usage, memory load, and output accuracy. Every change is verified. If it fails, the change is discarded. If it passes, the model refines it further. Over time, this leads to results that no single engineer could achieve alone. The loop keeps running until gains level off or a hard limit is reached. Perhaps the most important aspect is that Alpha Evolve is already optimizing itself. It has begun accelerating the training of the very models that make it possible. This sets up a recursive process. The system improves its own tools. Each cycle makes the next more powerful. This is not yet full artificial general intelligence, but it is a real-world implementation of the same principle. The system improves itself by design. As this kind of system evolves, we may begin to see new patterns in how software is created. Instead of writing code line by line, engineers could define goals, constraints, and test cases. The AI would do the rest. This turns programming into a process of guiding and evaluating, rather than building from scratch. For some fields, it could mean faster project completion and far fewer errors. The focus would shift from syntax and logic to clarity of vision. In education, this might change how people learn computer science. Rather than spending years mastering code structure, students could study how to set goals, understand system behavior, and measure results. The mental model of what it means to be a programmer could shift. Instead of being a builder, the engineer becomes more like a designer or strategist. This could open the field to people with different strengths and backgrounds. Some imagine using systems like Alpha Evolve to develop new technologies that are too complex for any single person to invent. These could include breakthroughs in drug design, energy systems, or encryption methods. The AI could run thousands of simulations and optimize results faster than any lab. Combined with robotics and lab automation, the process from idea to prototype could become fully automated. Others suggest these systems might someday manage full workflows for large companies. A manager would describe a desired outcome, such as a new product launch or an improved process, and the AI would plan, test, and implement the needed steps. Humans would approve key decisions, but much of the labor would be handled automatically. This would be a major shift in how organizations function and scale. There is also the possibility that people will rely on these systems for personal decision-making. From optimizing finances to managing health or learning paths, users might turn to evolution-based AIs to discover strategies they would never have considered on their own. This raises deep questions about trust, control, and responsibility. As these systems grow more capable, society will need to adapt not only its tools, but also its values. The changes Alpha Evolve brings are not limited to research labs. They are spreading into business, manufacturing, education, and science. If you define problems clearly, AI can now handle the solution. This shift is happening quickly. Those who understand what it means and act early will gain the most. The time to prepare is now. Learn how these systems work, not just what they produce. Focus on the structure of solutions and the evaluation of outcomes. The world of AI is moving fast, and Alpha Evolve is leading the way. This is the beginning of something much larger. Thank you very much for watching. Please like and subscribe.